Hello and welcome to this video presentation on risk management. My name is Ryan and on behalf of SEP Group 2, I will be going through the risk management plan. For the risk management plan, I'll be talking about the following categories: risk identification, risk analysis, risk planning, and risk monitoring. Risk identification has been split into 6 parts: technology risk, people risk, organizational risk, tool risk, requirement risk, and of course, estimation risk. In technology risk, we identify the risks involved with the technological aspects of this project. They are wireless connection failure between robot and graphic user interface, incompatible operating system or technology versions, robot software malfunction, robot hardware malfunction, example the sensors, or even an SD card failure. The next risk is people risk. This identifies the risks involved with the group members aspect of this project. Potential people risks for this project are unavailability of group members due to mishaps or accidents, team members falling ill, team members having other commitments like national service. For organization risks, we identify the risks in regards to the structure and organization of this project. In this project, they are conflict and disputes between team members failing to complete their tasks on time. Tool risk covers the risks involved in the resources used in this project. For this project, we've determined the following tool risks, namely unavailability of resources of robot to operate, version control system limitations like inefficient code collaboration and inadequate tools for development management, and not updated integrated development environment, meaning to say that we'll always be using the technologies that are old. Next, we cover requirement risks. This identifies the risk of not managing expectations and requirements properly. Some of the requirement risks for this project includes change in requirements of the proposed software design, difference in understanding of requirements between client and development team or within the development team, client failing to understand the impact of the requirements, hence resulting in delay in the project. Finally, we have estimation risk. This risk talks about the dangers of underestimating elements within the project. For this project, they are time estimated for delivery of software components, time estimated for repair of robot in case of damage, project scope underestimation resulting in inability to meet deliverables. This slide shows a summary chart of how we would be monitoring all risks involved in this project, categorizing into different groups. To measure impact of the risk, we have 3 different categories: low, medium, and high impact. Low impact refers to risks that have very little effect on the project. Medium impact talks about risks that have a significant effect on the project, while high impact talk about risks that have a major impact on the project. On the other side of the chart is the likelihood of a risk occurring. Not likely refers to a slim chance of the risk occurring, likely refers to a significant chance of the risk occurring, while near certainty refers to a really real chance of the risk occurring. With that in mind, we have used the chart to derive these 3 priorities as shown in this slide. They are high, moderate, and low. High priority refers to risks with high impact in order of those with more frequent occurrence. 2 examples of these are understanding the needs of the resource, last-minute changes of requirements. Moderate priority refers to risks with medium impact in order of those with more frequent occurrence. 2 of such are conflicts between team members and hardware malfunction. Lastly, low priority refers to risks with low impact in order of those with more frequent occurrence. 2 examples of these are IDE out of date and unavailability of group members due to an accident or mishap. Finally, I would now like to go through the strategies that we would deploy to manage the different risks. For high risk, the avoidance strategy will be carried out by ensuring careful planning, ensuring sufficient time is given to each component of the project, ensuring a common understanding of the project scope, having a good communication understanding and agreement between client and team. Indicators of potential high-risk occurrence in this project include failing to meet milestones, client requests conflicting that has already been agreed on. The plan to address this type of risk includes finding the root cause of the delay, looking for an alternative solution, and advising and negotiating conditions and specifications with client. We could monitor this by having multiple iterations of evaluation throughout the course of this project. For moderate risk, the avoidance strategy would be carried out by having multiple backup ready, maintaining good communication, and regular progress monitoring. Indicators of moderate risk occurring in this project include conflict and misunderstandings within team, inconsistent data received from hardware of the robot. The plan to address this type of risk includes constant checking and adaptation, for example, reassigning tasks to avoid delays. We could monitor some of the risks by having effective communication constantly to provide up-to-date information on the project. Lastly, we focus on low risk. The avoidance strategy includes ensuring similar versions of software being used, team members understanding their roles clearly. Indicators of a low risk occurring in this project includes noticing malfunctions within the system, noticing error messages. The plan to address some of these risks is to ensure redundancy and replication strategy is deployed, while the monitoring for some of these risks could be done by observation and effective communication. We have now come to the end of our presentation. Have a nice day ahead.